Hello students, next we will discuss how to find the dimensions of any physical quantity. Like we have discussed, we have basic 7 physical quantities, and by using them we can derive new physical quantities. For example, first we have density. Now what is the formula for density? That is mass upon volume. Now how we can represent mass? M in the square bracket. What is the formula for the volume? Length into breadth into height. So again we have 3 types of length. How we can write it? ML, this is 3 in the denominator, it will become minus 3. M1 L minus 3. And one more term should be here, T. T represents here time, and because we do not have anything in T, so we'll write T raised to the power 0. We can also derive SI unit from here. What is the unit of mass? That is kg. What is the unit of length? That is meter cube. So the unit will be kg per meter cube. Similarly, we can find out the physical quantity, dimensional formula for the physical quantity area. That is length into breadth. This is the formula. L into L. So it will be L square. Write m raised power 0 and t raised to the power 0. You can also write SI unit, that is meter square. Next is speed or velocity. The formula is distance by time. So again distance is length, L by t, so it will become LT minus 1. We don't have m here, so m is 0. And unit can be, for L it is m, t it is s, so meter per second. Now momentum, mass into velocity, so it is m into, what is the dimensional formula for velocity? It is LT minus 1. LT minus 1, MLT minus 1. SI unit meter, this is length, so it will be mass LT minus 1. So it is, for mass it is kg, for L it is meter per second, so it will be kg meter per second. Next is acceleration. For this we have formula, change in velocity over time taken. So velocity LT minus 1, we'll write in numerator LT minus 1, here T, so it will become LT minus 2. So SI unit will be meter per second square. You'll write it in the square bracket. We don't have m here, so m raised power 0, meter per second square. Next is force. So the formula is mass into acceleration. Here we have m, acceleration, this LT minus 2, MLT minus 2, and the SI unit is Newton. Next topic is dimensional formula. Now we have discussed the dimensional formula for the physical quantities. Now what is dimensional formula? If we represent the formula of the volume m0 L3 t0 in the square bracket, so this is the dimensional formula for volume, and this is the dimensional formula for the momentum. Now if we represent the formula like this, we'll keep force in the square bracket and put equal to and write the dimensional formula in the square bracket. So this will become a dimensional equation. So this is the this is the dimensional equation. Similarly, we can represent pressure also. Now, what are dimensional variable? Physical quantities which possesses dimensions and have variable values, they are called dimensional variables. For example, area or volume. We usually says that area of this marker is different, area of this scale is different, so different objects have different area. So area is a dimensional variable. What are the dimensions of area? That is L square. Okay, and it is variable, like for different objects we have different area. Next is dimensionless variable. Now physical quantities which have no dimensions, but have variable values. They are called dimensionless variables. For example, angle. For angle we have formula arc upon radius. Arc is a gain length, radius is a gain length. It will be cancelled, you will get 1. So the formula will be m0, l0, t0. It is a dimensionless variable. Like you usually write for the angle, like I take an example here. Here the angle is 30 degree between these two lines, and here angle is 90 degrees. So angle keeps on changing, but still it is dimensionless. It does not have any dimensions. Next topic is dimensional constant. Like variables, similarly we will discuss constant. Physical quantities which has dimensions and still are constant. So they are called dimensional constant. Example, gravitational constant. It has dimensions but its value is constant. Dimensionless constants. So constant quantities which have no dimensions, they are called dimensionless constant. Example, pi and e. These do not have any dimensions. Now let's discuss applications of dimensional analysis, means why we are doing all these things. The first application is to convert physical quantity from one system to another. Means we can utilize it to convert one physical quantity from one system to another. Means we can take an example. I want to change SI units into CGS unit or CGS into SI. Both are possible. To check the correctness of the given physical relation, if an equation is given to me and I want to check whether left hand side is equivalent to right hand side or not. Third, to derive relationship between different quantities, like I want to find out relationship between density, mass and volume. So I can get from here dimensional analysis.